Dockerize. So the pizza is still not here yet, and you can visibly see my annoyance. So I think it's just a good idea to just get going, because otherwise it will be very late. We'll just kick off, and then as soon as the pizza's here, I'm hoping that after the first talk, then we'll have a earlier break, and then just play it by ear, I suppose. But yeah, welcome to the first Docker London of the year. You've been looking at this slide for quite some time now, so I'm assuming you now know what the logo is looking like. For those of you who didn't see the Wi-Fi here, if you want to log on and tweet stuff, then it's possible, because that's the hashtag. For those of you who do not know me, I'm Dominique. It's this little thingy here. I work for a company called Technovo. I am the DevOps community advocate at said company. I'm also the community leader for Docker London, for Docker, which is pretty cool because they asked me to come to DockerCon in Barcelona 6 weeks ago, and that was it 6 weeks ago? A couple of weeks back. It was pretty cool because it was nice to have a couple of days in the sun in December. So as I said, you can find the hashtag and my Twitter handle there. We're live streaming this event, by the way. So they don't really see you, but I can turn the camera around. But people down in wherever you are, hi. Sorry, I kind of make fun of myself most of the time anyway. I just wanted to say a little something about our awesome sponsors. So first of all, thank you, Rightmove, for letting us use the awesome space. I'm not sure where Alex has gone. He just, hi. Yeah, he just darted off saying, oh, I'm on call, so he's now grabbing his laptop, I think. Monzo has kindly helped us with the food. They didn't order it. This is on me. Don't worry about it. So you sorry? No comment. In the bottom row is our trusted partners and sponsors over the last bunch of events. Katakoda, for those of you who don't know, is an online in-browser learning platform to learn cool stuff about containers and everything. Technovo is where I work, is a DevOps and cloud-focused recruitment consultancy. Oracle Cloud, yay, cloud. Rancher, sorry, I'm not. Anyway, and then Rancher is also doing some cool stuff with containers. Cool. I just wanted to run a few community updates by you guys as well. These are the next upcoming events. So on our website, on the Technovo website, we've decided to put a list of meetups to attend, like the cool stuff that we're there. So this is just the first couple of events that are coming up, but I'll send around the link again so you can see where everybody else is hanging out, because other groups are actually also kind of fun, so this is where I'll be. Another thing to note is that I'm also on the organization for the DevOps Days conference in London this year, which is pretty cool. Oh my god. Anyway, so the CFP is opened for that. If you want to submit a proposal, go to that link. And also the ticket sales have started. There are some interesting things going around with the early bird tickets, and you could also, if you would like to pay for somebody else's ticket who is an underrepresented group, you can buy an additional ticket, and that ticket goes to somebody who can't afford it or still wants to come. So that's quite cool. Take your pictures and slides and things and submit your talks. Right, so what are we doing tonight? Talking about containers. Okay, so we're actually kind of on schedule apart from the food, so I'm doing the introduction now. First up we have Igor. He's doing some awesome stuff about microservices. And then we've got Scott from Polystream talking about what they've done with their interesting infrastructure, and only 4 people doing so. So that's also kind of like, okay, what? And then technically we should have a break, but let's see how that goes with the food and everything. And then last up we've got Phil, which is actually, I'm very pleased that you're here to join us because he's from the States. And I was actually planning on having a different speaker on tonight. And when I asked for abstract, he was like, "Oh, yeah, I mixed up the Meetup group, so yeah, I'm not gonna I'm not gonna be coming." So okay. And then Phil, who I met at DockerCon, was like, he sent me and Cheryl an email saying, "Do you perhaps have a speaker slot available?" So well, actually, I'm down one speaker, so it actually absolutely helped us out here. So yeah, he's giving us an insider's look at the Docker engine evolution from of the last. I mean, it should have been 2019, I suppose, but this is now over the last 4 years. And then afterwards, see how we feel, and potentially, if the snow is not upon us, head over to the pub and grab a drink or two. So yeah, without further ado, I would like to invite Igor up on the stage and do his first talk. Give a round of applause.
Yeah. Oh,
Yeah,
should be
okay.
fine. Yep, perfect.
Could you say something and see if we...
I think everybody can hear me fine. Yep, all good?
So professional, right?
Oh, yes.
Cool. If it's not fine, but okay.
Oops. Okay. Hey. That's cool. Perfect. Well, it's gonna be a talk, to be honest, about Swarm quite a lot. The thing is that when I joined my current company, we were running like a big and quite ugly monolith written in PHP, and that was like that was 10 years ago it was written. And I was given a goal to generally deliver faster and safer. And well, we were facing a problem moving fast, even with that number of people we had. We planned hiring a lot more people, a lot more engineers, product owners, and we needed to go a lot faster than we were able to. Well, there were several solutions on the market at that time. The thing is that we chose a way of building what we call disposable products at that time. So the idea was that we go with immutable infrastructure, so we can literally build and destroy every day. We chose containers over instances at that time, so we considered using Packer and just packing all the applications into instances and just deploying them. Docker was, well, it was like 2014. Docker was relatively new to the market. It was quite risky choice at that time. And we were considering microservices as an approach, again, to make it disposable in a way that we can like build a piece, experiment, throw it away, replace with a different piece of technology. So we wanted to experiment fast, safe. We wanted to make mistakes and not be worried about making them and being on call and crash in production from time to time. And the goal at that time, it was not that clear, to be honest, the last one, but that was decided on the way that one of the main efforts we're going to do about going into microservices was to improve observability and monitoring and how we see the whole infrastructure and products together as one big ecosystem. Pizzas are here. So we built our very first microservice in early 2015. That was, what, 4 years ago. It was like REST API only service, no event model, just pure HTTP. It was covered by monitoring. That was Graphite at that time, I think, and probably with Grafana. It was plugged into this big monolithic product. Well, as a let's play with this and let's see how it works. And it was deployed traditionally, meaning that there were no containers. So it was deployed as a literally like uploading of artifact to some remote set of servers, unpacking and just making it work. Although it was automated and it was in PHP. And we went for Swarm. That was still 2015. There was no what we call Swarm mode at that time. There was Swarm Kit or Swarm, or now it's called Swarm, Legacy Swarm, whatever. So it was a set of containers quite close to what Kubernetes offers at that time, because it was just a additional layer on top of Docker offering you some orchestration. So it offered service discovery of some kind, so you could access services within, although you had to build, some HTTP layer on top of that, which listened to Docker events and allowed you to access services. There wasn't working, so in Swarm mode, in current Swarm, there is mesh routing, which allows you to easily access microservices. Again, at this time of legacy Swarm, it was not that easy to do. Well, we run actually what's called Docker for AWS. So it allows us to easily implement EFS and store some shared data in NFS implementation from Amazon. And so orchestration with Compose is quite easy, especially when you can utilize the same format of files for both local development and production generally. Again, at that time it wasn't there, but it is now. These are configs and secrets. It's not like full, obviously, secret management, but it's at least a storage you can use to store your data. But there were quite a lot of missing bits. So first of all, there was no job runner. Running one of jobs in Swarm was a pain. It was literally impossible. There was no scheduler as a cron schedule, not orchestrator. So you couldn't schedule some containers or set of containers to run as well you'd like to. There was no, and there is no auto scaling to the moment. So if you want to scale your instances and your services, you have to code something around this. There is no access control. Probably there is quite a lot of talk around Istio or something similar, but again, there is nothing like this in Swarm to the moment. And again, there is no request tracing, so when some packet enters your microservice infrastructure, sometimes it becomes quite challenging to understand what's happening if you have tens or hundreds of services talking together, So how did we do and address all of these things? Well, with Docker API, that's the answer, to be honest. So, for example, this shows just on a principle level how we addressed jobs. So you get a Docker client, then you deploy your stack, and then you just poll status of all tasks running and all services running, and you can just get status of them and, make sure they're finished. Something like this. Or that's how we address scheduler. So we just say that, we need this task to be executed every 10 minutes. Then that's the most challenging bit, actually. Then we set a lock across the cluster to make sure that several copies of a container, don't schedule the same job at the same time. And then we just execute it. Execute in this case means actually, going to previous slide, it means that we just schedule some Docker stack into Swarm cluster and make sure it's up and running and it finishes at some point successfully. solving auto-scaling, it's not, it is easy and it is not. The thing is that Docker for AWS allows you to synchronize process of adding nodes into auto-scaling group in Amazon and adding and removing nodes from your Swarm cluster, meaning that when you add just a new node or when you scale your group in Amazon, Docker for AWS automatically adds you one node in Swarm cluster and the other way around. So that part is solved for us with Docker. So there is generally a container running, just monitoring all this stuff and utilizing SQS and DynamoDB to do this. But what we need auto-scaling. So for that, we can monitor resources available on every node. For that, again, we use Docker API, so we can pull available resources, CPU, block devices, and memory from nodes, understand our limits, and if we are like somewhere close to limits on some percentage of nodes, so we understand that we might not be able to schedule a new service, then we can just add number of nodes we require to the cluster. With services auto-scaling, it is a bit more challenging because we have to define operational metrics like number of messages in like stacking queues. So based on that, we can understand that we need more power to and add more services and more replicas of our services. And from that, we actually can then see that we can add that many because we have that number of resources. And then our workers also scaling will trigger and add more nodes to the cluster. That's how we can shrink it both ways again. So then there is another thing, which is access control. Well, there is approach like I generally prefer to use, where we can define EM-like model utilizing like generally ready-to-go libraries where we can just set a list of resources, users, and policies around them. Then we can treat our services as users, meaning that we have to just give job token to every service, and then we can inject them via like Docker secrets, for example. For our customers who work with our services, we can say that, okay, we're going to use SAML, for example, and then we can have a single sign-on service to authenticate them. We can use two-factor if we want to, not for microservices, obviously, but for customers. And then we just need to implement some kind of regular token audit, so these tokens are refreshed regularly and, well, expire and whatever. And we need to create some kind of SDK to, well, to boilerplate our new microservices easily. But the thing is that for SDK, there is a tricky part because we don't really want our microservices to access this microservice on every call, because that's obviously going to be very expensive on network. So there is probably should be some kind of a module which you can easily plug in into your microservices, which will cache some access policies for other services to allow to reduce this time. Well, for that we have what we call Goblin, which is a microservice framework where we address quite a few things for microservice infrastructure, like managing different modules and runtime of a product, managing configs when our microservice runs in different environments, storage and cache where we want to access different databases, transport for both HTTP servers, clients, and WebSockets, how we monitor them. Well, in our case, we actually push metrics to Influx. How we log. In logging, the tricky part is, well, I'm going to talk about this in a minute. So ideally, we want to trace everything. And when we trace everything, the key part to have it unified across all your services is to have your trace ID or your span ID in literally every log message, which allows you easily jump from log message to a trace and the other way around. That's a key part, and it has to come through all your code, so you can pass this information. Every log message you invoke has this data, meaning that you can't really just say like in Go like logrules.info whatever. You have to write your own logger and pass it through context. We use health checks quite a lot. They're not really like explained, I think, properly, but this is a very vital thing in Docker to use. So Docker just says that, you know, you can just run a shell script and, well, your container will be dead if it's not executed correctly. The thing about health checks is that there should be some application within application which actually can assess that your microservice is alive and well and everything is fine with it. And defining this criteria of a microservice to be alive is a tricky one, because it depends per microservice, but again, it can be unified for a set of them. Like you can check that, well, simple thing, you can just create an endpoint in your web server and just ping it and see that it's fine, which is actually an example in Docker documentation, I think. But in more complicated things, like when you access file system or where you depend on message buses, for example, that's not that straightforward to check whether your service is available or not. And tracing itself, well, these were actually health checks. So visualization of health checks, so that's how you can see them if they fail. So if you push them to Grafana as if you push them to any time series database as metrics, then you can easily add them to a dashboard and visualize them that at that time that health check failed, and that's then easy to monitor across all your infrastructure to see that in this microservice that health check failed because of that. And well, tracing allows you to easily then see how customer query travels across your microservices. So it can be from incoming HTTP request then to HTTP client to another microservice, doing SQL queries to databases, doing queries to NoSQL databases, doing, well, pulling some information from message buses or sending events. Or it can be, well, we have quite a tricky thing done, which is tracing emails. Like when we send an email, we embed trace ID into headers of an email. It goes, well, to a customer, but when a webhook on email, for example, email opened, invokes, it reported back to us with that trace ID, so we can actually see delivery notification of emails in trace from customer requesting that email. Well, and there is quite a lot of stuff you have to build if you run probably anything. It's not just Swarm, so deployment of a cluster itself. So in a Swarm world, that's going to be traffic most likely. Then you have CI, then you have monitoring database in Flux. In our case, you have logging and tracing, which is Jagger. You may or may not have some kind of GitOps running where you have state repos where you store state of your microservices, because if you have like tens of them and your cluster for some reason fails without a backup, then you need to restore the whole system somehow, knowing that, you know, these services were deployed in those versions, for example. And then there is a question of secret management, because even Docker, Docker allows you to inject secrets into containers. You still need to have something like Vault or custom solution to allow secrets rotation and general identification of your services that new secrets arrive, something like that. Then, well, when we started doing microservices, we didn't utilize any kind of messaging except for SQS. And there was an interesting thing that we wanted to do broadcasting of changes to services, like when something changes in one container, we want to broadcast to all containers of that service that there is a change happened and you need to do some preload. So this was done using Docker API as well. So there is a separate microservice which generally can pull from the Docker API all the containers running for that service and just push some information to just those containers of that service. Then change audit in infrastructure, what was changing and when. If you run GitOps properly, then it's probably not an issue, but when you apply it to the data, so if you run any configuration databases, and if you store anything in SQL or NoSQL, then there is a question, how do you trace all the changes made to those databases? And how do you do email delivery, but not strictly related to the platform? And, well, monitoring. In our case, that's Influx, Grafana, Slack, and quite a lot of different TV dashboards running both Grafana dashboards and just custom software. Well, that's it. Thanks. Questions, please.
Come on, you can wait for a minute. Give him a
Yeah.
round of applause.
Thank you.
Question. Hello? Yeah. Question? Let's start in the front.
Hi, if you made the decision whether to swarm or not in this year, would you still go for swarm? Or would you consider also something else?
We because they have this ECS agent container running every. It was crashing for us, I don't know, like twice, 3 times a day per node, and that was like, no, thank you. After that, well, obviously, when you choose the technology, you have to invest into making it work. After we chose Swarm, we invested quite a lot into making it work, and it was fine for us. I understand that maybe at this time ECS is maybe not that bad like it was 3 years, 4 years ago when it just launched. But, well, that's what it is. Thanks.
Right. So I think it's some frequency. Another question? I'll go for back first. Sorry, did I get any? So professional, right? Talk mostly about myself.
It's better, actually.
Test. It's fine.
Thanks for the presentation. One of the questions I have is, a lot of these containers are deployed for interacting with clients or external users that are up on the desktop and things like that. In terms of metrics, are there, I haven't seen any that from your presentation, but are there ways of monitoring the responsiveness of the from a client perspective to be able to maintain a level of, client happiness? This is especially with interactions on the desktops or clients from the internet, let's say.
Interaction to
For example, people are accessing the services through Chrome or something. There seems to be no metrics available to monitor that or to alert that there's issues, because it could be, the processes could be halted because of a slow SQL query or a slow MongoDB query or something. How do applications improve if there are no metrics, right? So are you aware of any effort in that space to measure responsiveness from a user or client experience perspective?
And you can just quite relatively easily to measure response times on browsers of clients and just send this back, and in the background your clients will never, or probably GDPR, they should know that you can collect this data and just send it back to you.
But it would be nice if those agents or collection facilities are out of the box, rather than somebody having to spend time building.
I think there are.
Dozens of options in the market.
Yeah, there should be like tons of them. But probably people who build software on scale, they implement their own solutions because it's just easier for them if they have the whole monitoring system set up. It's relatively easy to implement.
Thank you.
I don't. Okay. All the way to the back. I'm sorry about the microphone stuff. It's
Back here. Just curious about the Goblin application. I think is that a proprietary in-house application that you've built yourself, or is it something that you've?
It is proprietary for now, at least. Yep. What do you use console for?
Oh yeah, it's most of the stuff that you've just mentioned over there. So key values of being able to then have configuration deployed to multiple services and so on. Yeah.
In our case, we wrote our own key value storage, but it's backed. So basically, key value storage itself is a microservice which is backed by generally open source, like a distributed open source solution. Because writing storage system for key value these days, it's uneconomical. What? We have a microservice which is a front end generally for a storage system.
Sure, this is good. Well, thank you. Thanks very much.
Just ask me. Okay. Let me
at the ready and get their lovely bums back in the seats? Well, that's a good thing because that means that people have eaten. It means that bellies are full, which means that the people are happy. Happy people is good people. Anyway. What? No fun allowed. Well, you came to the Meetup. Now, I like fun, okay? Anyway. Yeah, cool. Well, let's kick off with the second talk, I suppose. Scott? Oh, there you are. Did you get the thingo? Sorry, if you just hook this one up. I would like to invite Alex over on the. No, it's not really a stage, but like to the front because he basically helped me out massively. I've been bothering with so much questions. Like, can you help me with the chairs? Can you help me with the audio? Can you do things and help? So yeah. So I would like to let you say stuff.
Say stuff. Yes.
Wait for the people at home.
Hello. Oh, there you are. Camera over there. The chairman? What have you been saying about me? Okay. Right, okay. I see what you did there. No. A bit. No, it's a bit food coma, you know. So first, shout outs to pizza. Thank you, pizza. It was very nice. Thank you. Presumably sponsors.
Hello.
Like nice, happy sponsors for us. So thank you. Yeah. Yeah.
Options, things, like catering from already one.
And then, well, I'd also like to thank the speakers for speaking today. I am totally aware of how daunting it is to speak in front of a load of people right now, and so.
Tell us who you are, what you do.
Yeah. So sorry, I probably should start that. I'm getting coaching here as coaching live. So I'm Alex, and I work for Rightmove. I've got the little work shirt on there, and on the back, I've been as part of a hackathon. We hold a hackathon every year just for fun, trying to experiment and do crazy stuff. Not always property related, but so outside of the speakers, also want to thank I suppose Rightmove for being a cool enough company to actually allow us to run this kind of meetup. It's super. It's nice to be able to work with someone that actually understands, but it's not just about deliverables and getting everything done on time and all that, although that is kind of important. Also, I mean, probably haven't had enough praise for this. I want to thank Dominique here for being utterly tenacious in keeping this thing running. And she describes herself as a control freak. I can confirm that's true. Our discussions the last couple of weeks setting this up have been, there's been a lot of questions and some answers, every time. But I hope you're enjoying this, and I suppose it's time to roll on the second speaker. Yeah. Thank you, everyone.
Thank you. So without further ado, this is Scott from Polystream going to do his thing. You can, now close this one. So very high tech. For those of you who haven't seen, hidden behind the little thing, it's Rob. He's in charge of the live stream and all the audio stuff today. Kind of. I've asked him to, or basically said, "There's a chair behind there. We just sit there and push some buttons." So thank you. Right. So give a round of applause to Scott, and we'll get going in the second talk.
Hello, thank you very much. This talk entitled 4,000 Containers for Engineers, it's not supposed to be impressive at all. I mean, it's more about the journey that we took to get to this stage. I mean, we're a very, very, very small company. The team is actually now 5, so apologies for that. When I offered the talk, there was only 4, but we transferred someone from a different team, which is quite nice. Yeah, so it's about our journey and more around operational stuff more than just deploying containers, right? Deploying containers is easy, but how do you keep them up? How do you monitor them? How do you know things are working? So I am Scott Perham. I used to work at Microsoft before I was at Polystream. I worked for a game company called Lionhead, who some of you may know. The project I was working on got canned, and in typical Microsoft fashion, the entire company got shut down and everyone got sent on their way. About the same time, a couple of people, Bruce Grove, who's the CEO of Polystream, and Anna Billiard, who's the CTO, came together in Guildford. They'd been working on something for quite a while, and they decided now was the time to really push it. And it just happened to coincide with the tearing down of Lionhead. So he managed to grab a few people from there, and we started Polystream. So Polystream is a cloud gaming service, essentially game streaming. It's obviously streaming is not a new thing. Streaming's been around for a long time. Interactive streaming is the obvious next step, right, from CDs and video and things like that. But there's a problem. Everyone's trying to do it in the same traditional way that they do video streaming, which is just take a GPU in the cloud, you just run something through it, and then you take the output. The problem is it doesn't really work because it's not scalable, right? There's not very many GPUs in the world in the cloud, especially those with encoders on. And even the ones that are being virtualized, you still need an awful lot of power. And that power costs money. And then they transfer that money onto the end user, or in this case, the business that's running it. So Adam Billiard came up with a new way of using command streaming instead of graphical streaming. So we use the power of the client to render the scenes, and we use commodity VMs in the cloud. What this means is we're not restricted to using AWS and Azure and Google Cloud and things like that. We can basically use any data center anywhere in the world, which has some very, very interesting challenges. So when I first spoke to Bruce, he said they'd already done their proof of concepts. They've shown that the streaming worked. They've got their angel investment. Everything was really great. Now they needed to prove that it could scale. And one of the USPs of the Polystream platform is that we can run from any data center. So just running something in Azure isn't really interesting to them. Running, a couple of VMs somewhere is not interesting. We need to show that it worked at scale. So these requirements of at scale and being secure and always up and everything else, these aren't abnormal things, right? Every platform aspires to have these things, but we needed these things from day one, which was interesting because I was the only service person in the whole company. I said the whole company, there was 5 of us at that point. So yeah, it was interesting. So I took my kind of Microsoft background and I kind of ran with Microsoft-based stuff. It was the easiest thing to use. So spun up some virtual machines in Azure to prove that we could do this stuff concurrently, and a couple of sort of full-blown cloud services. I don't know if anyone's used cloud services before, old-style cloud services, but they were essentially entire VMs running one service. So they took a long time to spin up. They were quite hard to manage, and when you wanted to kind of do updates and things, it just took time. It was, it's not the easiest thing. I had kind of history in managing these things, but it's not the easiest thing. So it wasn't very long before we kind of had these things up and running, and we could prove that we could run things concurrently, and everyone was very happy and looking for new investments and things like that. At that point, I could kind of take a step back. We employed another guy, so I wasn't on my own at that point. And I kind of set out a bunch of principles, things that we were going to kind of aspire to, I guess. The first is obviously cloud first. It's not really cloud first, it's cloud only. We don't really have anything that's not in the cloud. We are provider agnostic. We have to be provider agnostic. We can't be locked into any one vendor, because then that breaks our message of being able to stream from anywhere. I mean, one of the key things about streaming is it gets a really bad rep for things like latency, which although is not really an issue, it's perceived as an issue. So as soon as we can run our VMs in your data center down the road from where you live, it really helps. So if you're in Warsaw or something, the nearest data center of GPU is probably in Frankfurt, well, we can run it in Warsaw, and then that latency goes to nothing, which people really like. Lightweight deployments was really a kind of an aspirational goal, I guess, from being in that kind of cloud background with big, heavy VMs. Deployments are a hard thing to do. You kind of have to notify everyone, and you've got to wait, and there's going to be downtime, and it was a real pain. So I really wanted to try and get to lightweight deployments. I didn't know how I was going to do it at this point, but that's where we wanted to get to. And telemetry and events, as the last talk, I mean, monitoring is hugely important, and we knew that this was going to be a globally distributed platform, and we're all in a little shed in Guildford. We couldn't operate this thing without telemetry and analytics. So every single service we wrote had to have this in the fabric of it. that it really understood how to send this stuff out, how to tell us whether things were working or not. Didn't always work, but that kind of, it was a goal. So then after we had some things running and we kind of got together and we were talking about how we're going to move this thing forward, we started looking on the internet for how things are working nowadays. And containers had been something that's kind of been bubbling away over the years, and it was slowly gaining momentum. And we thought, sod it, let's give it a go. So we kind of read some blogs, and we just sort of thought, well, how hard can it be, really? So we spun up some stuff in Azure. We used Docker containers. There was a thing, I don't think it's even around anymore, Azure Container Service, which was essentially gave you the option of Docker Swarm, I think, DCOS or something like that. But, so we used Docker Swarm. It seemed like the obvious choice if we're using Docker containers. We did some proof of concepts, and it all worked really well. And then we had to start spinning up these clusters on our own, because we couldn't rely on these managed services, because most data centers in the world don't have managed services for containers. A lot of people hear about the bigger ones, even AliCloud and stuff like that. They have these managed services, but Joe Blogg's data center down the road doesn't. So we needed to kind of bring containers to the data centers that didn't have containers. So we decided to do this. And then we started using containers in anger. We had containers everywhere, and it was brilliant. And then we came up with this idea that we're going to do container-first engineering. And the first thing is, well, that's, container-first engineering is not really a thing. And you think, why isn't it a thing? Because everything's first nowadays. And the reason I don't think it's a thing is because you get test-first engineering, you get API first, and you get security first. The idea is that they apply restraints on things. And they restrain you so that you're ensured you kind of force down a path to make sure everything works the way you wanted it to work. The great thing about container-first engineering as a thing is that it removes a lot of that stuff. You don't have to worry anymore about the environment it's going to run in. You don't have to worry that we're going to run this thing in the cloud, therefore it has to work like this. You don't have to worry that when we come and we want to upgrade our .NET deployment, will the VMs be okay to do it? What's the path to update these things? So we decided that everything now, we're not going to worry so much about it. We're just going to include a Docker file in every service and let the engineer who's working on that service determine what the dependencies are and how that service is going to run in the environment. What it meant is that from a really, really early stage, kind of DevOps was really a thing for us. The engineers were responsible for determining exactly how this service, I say the engineers, it was me and another guy, but we determined how these services were going to run. And obviously we knew that we was going to grow really fast, so we wanted to make sure that anything we wrote wasn't just throwaway stuff. It was stuff that we could keep going forward, and these are principles that we could apply as the team grew. So yeah, so we had many clusters around the world. I think maybe, 6 or 7 swarm clusters scattered about the place. And we could kind of see this sort of mist on the horizon, and as it came closer, we realized that Kubernetes was around. And yeah, so it was something. It kind of, for us, it sort of felt like it sort of jumped out on us a little bit. And when you sort of look into this thing a bit more, the community support was massive for this thing. Obviously, its background in Google was it was already a tried and tested platform. You really need to use this thing. Azure and AWS at the time were announcing Kubernetes only services. So we started to sort of panic a little bit. It's like, oh my God, did we make the right choice when we chose Docker Swarm? So we sort of took the hit, and we decided as a kind of a gamble, I guess, but I guess a measured gamble, that that we'd move to Kubernetes. So I should have changed that slide earlier. There's also, loads of blogs. Loads of people talking about their move to Kubernetes and how great it was and how wonderful it was. They didn't tell you how difficult it is to set up a Kubernetes cluster. It's not easy, especially because we're setting these things up in some random kind of unknown data center. UpCloud, for example, in Helsinki. We run some stuff for Slush every year, and we run a region up there. So we just set up some machines, and you install Kubernetes on it, and it's a challenge. So we now have Kubernetes clusters all over the world instead of Docker Swarm clusters, and we have thousands of containers running all the time doing various things, and we bring them up and tearing them down. And everything's brilliant. And then what is the inevitable question comes when Bruce, our CEO, comes up and says, "By the way, I'm going to Bratislava next week. We need to make sure something's running there. Does it work?" And we're like, "Probably." Because no one really knows, because there's so much stuff. So it's not that we're sitting there thinking it doesn't work, but we're kind of a little bit oblivious to the fact that things might not be working. So what do? How do we know that these hundreds and hundreds of service instances that we're deploying are actually working? And the answer is obviously telemetry. But essentially, we come up with these things. So we actually came up with these quite recently. We're defining our kind of service level objectives and how we're going to determine whether things are up and things are working. So we thought to ourselves, we need to make sure, they ask us the question every time, how do we know it's working? Whenever we deploy any container, we want to know it is working. So how do you know that? Once you figure out it's not working, or it tells you in an ideal world that it's not working, how do you then find out what the problem is? Because again, something could break, in a message queue. Actually, the source of the problem is because someone sent a ridiculously large payload or something like that. And then the other one, which is the hardest problem to solve at all, really, is did it break when I wasn't around? Because then as soon as you look at it, you have this kind of weird kind of Schrodinger's cloud service issue where as soon as you look at it, it starts to work because the act of poking it brings it back to life. So these are all things that we decided we need to try and figure out. The first thing we did was heartbeats. So we use the health check services in Kubernetes and stuff like everyone does. But we have a kind of a cloud agnostic operational model. So we need to make sure that our operational dashboards don't rely on certain things. So we needed this kind of single method, if you like, for monitoring the health of the services. So we had two types of services. We had the domain services that we wrote, which are obviously very easy. You just write some code and it will send some heartbeats. And then we had our third-party services. We had message queues and we had event streaming stuff and things like that. So we used this sidecar pattern of having another service that pokes it every now and again to say, how you doing? Got any stuff for me, kind of thing, and then send off some events. It turned out to be really, really, really efficient, actually, in doing this. So much so that we're actually in the process of moving all of our service heartbeats into this model, because it suddenly means that your domain service doesn't have to worry about sending heartbeats, worrying about having some other thread sitting there monitoring things. It just sits there and does its job, and something else is in charge of saying, are you okay? And it works really well. So now we have lots and lots and lots of telemetry. We've already said that telemetry is absolutely first class. It sits at the kind of the bottom layer of every service. We send telemetry, we send a lot of telemetry. We also had this requirement from the network team, that network team being one guy, that we wanted per frame technology. We wanted to know how long the compression took for one frame in any one stream on the server, for example. So we started sending events every frame from the client and server. So this is, say on a 30 FPS game you're playing, obviously that's 30 events you're sending per second from the client and 30 events you're sending from the server. That's 60 events a second from every stream. We have to process that, ideally in real time. It's obviously not in real time. But as close to real time as you can, and obviously maintain it. And it's not an easy thing. So, like most people, I think we decided it was kind of a build versus buy kind of thing when it comes to our telemetry pipelines. We did look at other things. We looked at Logstash. We were using Elasticsearch at the time for putting our devlogs in. We looked at Logstash. It wasn't really performant enough for what we needed to do. So we decided to roll our own. Why not? I mean, again, how hard can it be, right? There's two of us and we got in a massive distributed platform. Why not spend some time writing our own service? Yeah, I don't know. With hindsight, you think maybe not, but it seems to work, so it's cool. So we wrote this thing called Teleminium, which is very similar to Logstash kind of in concept. It's a customizable pipeline. It has its own kind of expressive syntax to describe these pipelines. It's entirely cloud native, obviously. And it's a plug-inable architecture. So we have one service, and you can plug in an HTTP listener to it and send it through, do some modifications. Unlike Logstash, you don't have to create plugins for manipulating the event as it goes through. It can all be done in real time. So what this allowed us to do is, like I said in the previous talk, when you want to trace messages and events from a service somewhere, we don't really want to put too much information. We don't want to configure a service to say you are running in Warsaw. We just want it to be a service that's just sitting there doing its job. So as it sends its event, everything goes through these Telemini instances, and each one has more awareness of where it is. So it tags the events on the way through. So what we end up having are these kind of standalone single responsibility services, but by the time the telemetry gets to the other end, it's completely enriched with all this stuff. We've had spillage on the floor. That's all right. It's not your office. It's cool. Yeah. So the other thing we do obviously is trying to collate this information in order to get some kind of holistic view of the platform, because there's a lot of providers, a lot of services and everything else. We use event sourcing for our kind of operational dashboard stuff, so it kind of collates, it listens to Kafka and collates all these events and builds up its own little snapshot of what the service state looks like across everything. And everything worked really well, and it's kind of going good, and everything's great. We had these teleminions, we started using them everywhere. We ended up with about 40-something different configurations of teleminion around the world. Essentially every component that spoke to another component went via a teleminion for some reason. The problem with that is that you end up with ridiculous amounts of configuration. So we had, our CI builds were pumping out we check in a teleminion instance, and it had to go and recreate 40 or 50 container images, each one with separate configuration, because we didn't know what else to do. I mean, up until this point, we were deploying using PowerShell and ARM templates and stuff. We also found that because we were doing everything with ARM templates, we started to slip a little bit on our cloud agnostic stuff. You know, it was easier to use ARM templates we already had than go and try and figure out how we provision something new in Cloud Sigma. You know, so it was hurting us a little bit that we weren't managing this configuration properly. So we turned to Terraform, as everyone does nowadays, right? Everyone uses Terraform. It's a great thing. You know, we used it. It's a lot of community stuff. It's a tried and tested configuration management system. It's kind of plug and go, although we've had to make modifications to almost every module we use. You know, and it is easy to integrate. I mean, it's a good thing. It takes a little while to kind of get it working and, you know, really figure out how to use it properly. And we're kind of on our second iteration of how we manage these configs. But we're sort of in a good place with it now. Yeah, and it seemed a good idea at the time. I mean, it's slightly more tricky when you go true cloud agnostic, and Terraform isn't really that. You know, you still require TF files for every single provider you want to integrate with. But anyway, so now we're in an even better place. We have a configuration. We've got all of our config in GitHub, and we have our configuration builds, and we've got everything, and we're in such a great place. We think, let's use more containers, because containers are solving everything for us. So what we ended up doing is we started to think of different places we could use containers that were going to help us grow. Because again, at this point, there's probably 3 of us, maybe 4, I can't remember. Yeah, so, you know, containers are helping us big time. So we said, well, where else can we use containers? So we have quality of service servers that we run around the world. So when we determine where the best stream is going to be for you, so, you know, you're in Warsaw, for example, you want to ping a few servers and say, well, actually, even though Warsaw might be physically the closest data center, just because of who my ISP is and peering agreements and everything, it's actually quicker to go to Czech Republic or something. So we have these ping servers, and they're essentially just standalone Linux VMs that just run a service, and, you know, everything's really great. But actually, we still have the same issue. We want to upgrade .NET. Well, we update .NET Core. We now have to go and update all these machines, and then we've got to run them side by side to make sure things roll over properly. So we decided, well, let's just pack them up in another container. So now we have a machine that just runs a Docker engine that we just throw a container on. And it works brilliantly, because our upgrade path is so simple. And then obviously we want to roll back because things don't work. Again, it's really simple. You haven't got to worry about any state that you might have done. You haven't tainted the machine in any way. You just throw a different container on there. Our CI builds, as I sort of said previously, that every service builds its own container. So you check in some code for a service, or, you know, our kind of underlying infrastructure stuff. The service is the code's in GitHub. It gets built by Azure DevOps, is it called now? The TFS, TFO, online VSTS, I don't know, whatever. It runs through the pipeline and does the builds and does tests and all that kind of stuff, goodness, and then ends up by building this Docker image that pushed into our repo. We also, now that our configuration is in source code, we have builds for our configuration. So as soon as you check in a new configuration, it might be maybe a service version update or something like that, that kicks off a CI build, which in turn takes all that information. We take the Terraform files, and then we build a container that contains everything you need to run Terraform. So essentially, the command line, the execution is Terraform, apply my stuff. You know, and again, it works really well because this allows us to get to that point where deployments are lightweight. But all we do now is we can take those containers, because they're in our Azure CR container repository, from any machine that has a Docker engine on it, we can deploy code, we can deploy services. But more than this, it means that with our our deployments as containers, we can now deploy these things at runtime. So we can spin up new regions without engineers getting involved. You know, from our operational dashboard, we can say we want a new bunch of agents running in, I don't know, San Jose or something. You click a button and it creates a Kubernetes job that just runs these containers to go and create new services. And because we have all our heartbeat stuff in every service, and every service is responsible for telling us how it's doing, as soon as that comes up, we know that the service is there and it's instantly monitorable. We also don't have any kind of service discovery, apart from what's obviously inside Kubernetes. We don't have our own service discovery. Everything is dynamic. So the existence of a path to a service means that that service is there. And we use teleminions in the middle. So we used to use RabbitMQ shovels, as I've used them before. It's really good. It does the job. It takes messages from one RabbitMQ and shoves it in another RabbitMQ. But it's not very open about how it does things. And the events you get out of it aren't great. It kind of says, I couldn't do it, and that's what you get, really. So we use a teleminion in the middle that has a RabbitMQ input and a RabbitMQ output, and we can actually manage the bits in between and say, well, I couldn't route it because there is nothing listening to the queue, or because, you know, the queue's broken, or whatever. Or something that happened recently, our RabbitMQ cluster split in two, which was really odd. Never seen that done before. And also, so the final thing that containers kind of give us really is that we can just throw stuff up there and just try things out. With Kubernetes, obviously, we just go and create a YAML file, and all of a sudden we've got something tested. So this is really useful for, again, we're being a very, very, very small team, and obviously most of these operational challenges we face are because we're so small. But because we're small, we want to go and try out something with Splunk or something, right? We use an Elasticsearch, we're throwing our metrics into Datadog, it all works really well, but actually what if we used a slightly better managed service so we don't have to worry about Elasticsearch anymore? Well, we can now just create a teleminion, we write a bit of config, we throw it up as a service. Because it's listening to Kafka, it grabs all the services from the beginning of time, however long we've set that retention period to, and instantly you've got all that data in there. And you now have a standalone service that is being monitored, it's part of the platform, but actually you haven't really had to do anything to get it up there. And there's no real operational overhead. So that kind of brings us on to where we are. This is really bad diagrams now, so I apologize. So our topology for the platform is hierarchical. We have obviously our global kind of infrastructure-y kind of operational bits. They go out to centrals, which is kind of the point of presence for the platform. It's where clients call off to determine where they're going to get their stream from. And then that gets farmed out to regions, and then beyond regions you have your actual streaming agents. So it's very much a hierarchical thing. And if you look on the right-hand side, that kind of diagonal down there, there is a kind of slice of what our architecture looks like. Again, I apologize. So from kind of right to left, this is sort of a global central region, and then at the very end is a streaming agent. And each of these, so this section here is a Kubernetes cluster, this is a Kubernetes cluster, and that's a Kubernetes cluster over there. And how are we doing time? All right. So we use RabbitMQ. So we have RabbitMQ in each of the clusters. That's obviously how we do our discovery. We use AMQP. It works really well. And our messages flow from right to left with kind of a request response kind of thing. And then we use Kafka for our event streaming, getting all our metrics back up. Because again, this stuff's running in lots and lots of different data centers across the world. We can't hold things up when we're sending these telemetry events back. And ultimately, everything needs to be aggregated so we get this kind of holistic view without going to lots of different dashboards and things. So we use Kafka for that. And all the events, as they get sent back, they get tagged, and ultimately stuff gets back. We do kind of siphon things off from time to time to different places. But a lot of our telemetry ends up back in our kind of global, that we call. We have a lot of teleminions running. I put a question mark because we don't have an icon for it yet. If anyone wants to create a little logo for teleminion, you're more than welcome. We have lots and lots and lots of teleminions. It probably makes up about 80% of our platform is this one service. It's so easy to configure and it's so easy to deploy. You can kind of just knock something up on your machine, test it, throw it up there and just see what happens. It's really useful. So I guess to summarize really, we have this dynamic topology that we don't have any kind of central registries of services. We haven't got a single point of failure. If that goes down, then all of a sudden you can't find anything. We use containers and more specifically deployments of containers at runtime. Lots and lots and lots of telemetry, and everything is monitored via our operational dashboard. I should have put a slide about a dashboard. It just doesn't look very nice. It's just tables and tables and tables of stuff. And there's a hell of a lot more. So the future, no one really knows what the future looks like, right? We work on a startup. It changes all the time. You know, the business vision will change from, well, maybe not daily now, but you know, it changes quite often. But we need to try and stay kind of ahead of the curve, really, and containers and Kubernetes specifically. I'm pretty sure there's a Docker meetup. It works, you know, and it kind of puts us in a good place. So we'd like to get to the point where we can have automated deployments. Obviously, everyone loves automated deployments. They're a bit of a unicorn. Never really worked anywhere that's done it properly. Everyone says, yeah, we can automate deployments. But really and truly, there's still a guy sitting there pressing the button, watching the log. Intelligent scaling is interesting for us. We still use full-blown VMs for the streaming. You know, we need a Windows operating system for that. Windows containers are just too slow at the moment. So we'd love to get to the point where we can, you know, scale on demand, but it's a hard thing. We don't know how we're going to solve that yet. Containerized streaming agents, we would like to get to that. We think that will help with the intelligent scaling. We have some proof of concepts running streams from Windows containers, you know, which is a brilliant thing. If you think at the moment, game streams run from massive VMs in the cloud with huge NVIDIA grid GPUs attached to them, and we can run it from a container. I mean, it's massive. The scale is just, you know, beyond anything that's available at the moment. Larger scale, I mean, most of the people that we talk to, the people we work with, the publishers that we work with and the game companies, they always want, as soon as they hear what we do, they want to do it big. You know, no one ever wants to say, yeah, go on, run 5 streams and see how it goes. You know, it's, yeah, we want thousands of streams. We've got this massive event over the weekend. We want you to stream all these, you know, millions of things. So it's going to get, you know, very, very, very big. If you're not fancy trying it out, you're welcome to. We have a demo on demo.poly.stream. Don't do it from a mobile, it doesn't work. And don't do it from a Mac, because it doesn't work. You have to do it from a PC, like a proper computer. Sorry. Yeah, exactly, that's fine. Yeah, so, and you know, give it a go, it works, it'll do a little speed test and make sure you're within range of a decent data center. And because I'm giving a talk at a meetup, we are obviously hiring, because you're not allowed to give a talk unless you have a we're hiring slide.
You are.
Who said that? Oh,
you are allowed to do that without having a slide like this, but it's fine.
I think we have to. We're hiring across the entire business. I mean, I'm obviously very interested in the platform, but across the business. And any questions?
Mine's not a question, it's a comment.
Oh, go on then.
You realise your proper computer comes with Candy Crush installed on it, right?
What's wrong with Candy Crush?
Anyway.
Just saying.
Yeah,
Do we have any questions?
Oh, I thought I was going to say awesome.
Does this work? Yeah. Excellent. You mentioned Windows containers being too slow. Do you mean too slow to start?
Yeah, too slow to start up. I mean, from a runtime point of view, it's just Windows, right? It's fine. And we run on Windows now. There's business reasons why we run on Windows. There's business reasons why we stream to PCs opposed to anything else. But yeah, it's the startup time. I mean, we've been playing with Server Core. It's a couple of minutes, really, you know, before it's really up and
Have you
running.
done anything with 2019?
Not yet, actually.
2019 is much better.
There's some interesting licensing issues.
oh, yeah, always.
Yeah.
But the technology is better.
Yeah, that's all right. We'll just stream from Linux containers. It'll be fine.
Cool. All right. Next question.
Very quick one, just about Docker containers on Windows. I assume if you're just doing a bit of local dev, you might run into the issue of Windows containers running into a memory limit. So at the moment, essentially, if you want to run Windows and Linux containers side by side, if you've got some sort of stack.
No, well, actually, we don't run Windows containers.
Okay.
Generally speaking, I mean, the infrastructure builds we create are Windows containers, but the actual we don't really run any containers with Windows.
Mm-hmm.
So all of our quality of service stuff, the stuff that we just run as a container on a single engine, that's always Linux of some flavor, various flavors. All of our services run in Linux. We use .NET Core for that reason.
Mm-hmm.
We develop on Windows machines, but we run it there. If we're testing anything locally, we tend to just run it in Linux containers.
Very cool.
Yeah.
Thank you.
Sorry.
Cool. Anyone on this side of the room, maybe? I mean, the questions have been coming from this side so far. No? I mean, give a round of applause.
Thank you.
Cool. Very cool. Anyway. This is. That's Kip. That's my colleague. She. Anyway, I'm not the only one in my company that's weird. And that's the other weirdo. I'm sorry. It's very, we're having fun all the time. Anyway, how much of an urgency for beer do we have? Because I think we have had a half an hour break, and I think we should we should carry on with the next talk, right? Yeah. All right. Cool. Well, last up then is Phil. There's a pluggeroo. We got a sound guy. Oh my god, it's so professional. How's everybody doing? Still all woo. I mean, you know. Who have ever Sorry? I said it's January. How woo do you get in January? To be honest, for some reason, I don't know why, but January has gone so slow and so fast at the same time. It's like it feels like it's January 47th or even longer. I don't know, but it's also like January's already done. Like it's so I also was thinking I should go into stand up, but I'm not quite sure if I should do that. Most of my jokes are not funny. So while we're dealing with some tech problems, because that's always the case. Yeah. Give me 1 second. Presentation modes, that's cool. 1080i? Yeah. Please don't leave. So, did everybody with the hashtag? Sorry, I'll stop. So I might as well just grab a beer, I suppose. Oh, I think she's going to get beers for everybody. This is direct, right?
Yeah. TV's not playing.
Okay, so this is direct, but that does mean that the people at home don't see stuff now. Is it? Oh, try the other one. There are actually people watching at home. Okay, I've been people messaging me saying, "Oh, the stream is so much better than the Christmas one." So that's a thanks. So, does that do anything? It's great that I don't have to deal with that myself right now. Oh. Yes? No? Oh.
Is that me?
It did do something.
That's me touching it. That's not good.
Maybe the cable was dodge. You did change the cable earlier, didn't you? This is the...
That's the best we'll get told now. Keep it.
Has anybody tried one of those VR things yet? Shots fired. I'm not going to get involved with this.
I could switch back to this one and get my power. Sometimes adding power, I don't know why they do that. But sometimes I think it doesn't play with power. But the only way it was working before was just direct, not going through a switcher.
Fine. Okay, so, well, sorry. I'm gonna log off. Anyway, this is an exclusive for us here then.
Yeah, sorry about that.
It's okay. Stuff needs to do things here yet.
720.
Still no signal. Yeah, yes. Woo. There's some fiddly bits on the side.
Can we use 80%? What the hell do you feed that things going on?
Nothing.
That's a problem.
It's not. That's not my. This is not my problem.
It's actually not.
If nothing happens on the side, then that's fine.
Yeah, I mean it's actually. Oh wow, look at that.
So this is not my skit at all. This is just going straight into the TV.
Let me.
Have you tried turning it off and on again? Sorry. That's most of the time.
I think it was okay direct.
I think that was direct.
Yeah.
Still.
I think you've got your res set up wrong.
Yeah, I mean it says 720p, but.
Yeah, but the meter is crap.
That's for Sony TV.
Yeah, I mean.
That one? That function above scale?
Oh, but that's gonna switch back to like 1080.
Yeah, but now you're plugged in.
Oh, yeah.
It shouldn't matter. Hey!
Oh.
Yes, I did.
Okay.
That's fine. I used to sell Apple computers for 5 years. So. Okay, so I think we're on now. So give a round of applause for Phil. All the way from the States.
All right. Well, that was the first 5 minutes. Getting image on the screen. So hopefully things will look up from there. So you've gotten two actually really nicely done kind of end user, what I would call end user talks. We're going to shift gears way to the other end of the spectrum. Hopefully I can keep your interest. But the containers that people are running, we just keep saying the word Docker, but what does that actually mean? What's underneath that, and how has it changed in the last 4 or 5 years? And so that's what I'll take you through, what's been happening at that level of the actual Docker engine itself. Hopefully I'm a reasonable person to do that because ignoring the title and all those other things, I've been a maintainer in the Docker engine since about 2014, late 2014. So I've been contributing to Docker upstream, and then that became the Moby project, and then Containerd. We'll talk about where that came from and what that is. I'm a maintainer there as well, and part of the foundations and projects that are over this part of the ecosystem, like the Open Container Initiative. We'll talk about what that is. I'm on the technical oversight board for that. So I spend a lot of my time focused upstream in open source around containers. I do that on behalf of IBM. So I work for IBM Cloud, and we're that cloud that when people list Amazon, Microsoft, Azure, Google, sometimes they'll say IBM Cloud, but we'd like to be in that list someday. So that's what we're all working toward at IBM.
You're coming after Oracle.
Yeah. Oh yeah, and Oracle. So you've heard a lot about containers. I found this amazing phone booth over by the river yesterday. So no, we're not going to talk about C containers, but as a really bad dad joke, we will talk about OCI containers and what that means. So yeah, the Docker engine. All evening, people have been talking about building Docker containers, running Docker containers. Who here can claim they used containers before Docker existed? Anybody? It was possible, right? I see a few hands. So Docker did not invent the concept of containers. Linux had a set of technologies that existed, mostly in the Linux kernel. There were other projects, LXC, maybe some of you heard of that or used it. There were cool kernel developers, hand creating namespaces and running things in containers long before that. But 2013, about 2013, maybe some of you were playing around with containers then. Into 2014, I would say is the huge curve where all of a sudden everyone's talking about Docker and containers. And really the core of that was something we call the Docker engine. That was the open source project that the company at the time that became Docker Inc. Released and gained huge popularity. For those of you that did play around with containers with LXC or other ways that you could use those Linux features, I would say two of the main reasons that I think Docker sort of took the world by storm is they really consolidated all those capabilities that you could get from LXC or you could get from knowing about those kernel features and writing scripts to kind of mash together a network namespace and a PID namespace. They put all that in this one binary that you could put on a Linux system, and all of a sudden you had a client to run containers. It had a daemon that could manage these container processes. It had a build tool with this nice Dockerfile concept where you could say how you wanted to assemble a container image. And then I think the second piece of that, so the consolidation and simplification of all these complicated features into this single tool, the second piece of that was to create Docker Hub and the Docker registry where you could actually share the output of this container image. You can now share it and use it, either share it with the world or use it within your company or stand up your own private registry. And so, for those that use Docker in that era, all of a sudden you became very comfortable with these commands: Docker build, Docker run, Docker PS, Docker push and pull. And so, the first couple of years, again, that's about the time I got active in the open source project. Everyone was falling in love with this use model and trying to add all kinds of new capabilities, new features, support for different platforms. And that's where IBM got involved. We wanted to bring it to our Power systems and our Z mainframe systems running Linux, but on these other architectures. Raspberry Pi enthusiasts got involved and made ports for ARM, which today even Docker still supports ARM and ARM64. So there's a lot of activity in these years, but really at this point, Docker is a single binary on your system. Everything is packaged in there. There's a component called libcontainer, which is really what's talking to the Linux kernel and assembling the container features for you at the time. But all this is really being assembled into this one binary, which again is easy because now there's a single file I can copy around to my servers, and magically I have Docker. But it was also at this time that not only was LXC around already, but you had other ideas about how to assemble these same capabilities into different tools. And so CoreOS created Rocket, which was an alternative to Docker, some different ideas about how to assemble images, how to run containers. And for those of us sort of more intimately involved in that era, you can think of it sort of as the container wars era of trying to make sure that there wasn't a huge splintering of the community in different directions. And so we're going to walk through this in more detail over the next 10 or 15 minutes. But essentially, we went from the single sort of statically linked binary to a set of different binaries and even different open source projects that now comprise, you can use that same UI, those same commands, but today the daemon is separate from the client. The daemon is talking to something called containerd. Again, I'll explain what that is in a minute, which actually drives runC, which is an even lower level. That libcontainer component I mentioned a few minutes ago, that was contributed to the Open Container Initiative and became its own binary. And so today there's a series of binaries that when Docker is packaged have to be available on your installation for Docker to actually operate. Docker then said, you know, everybody wants their feature inside Docker. How about we make certain parts of this pluggable? And so as Docker has continued to grow, there are ways to have your own networking implementation or an external volume storage driver, and so on. And so let's talk through how Docker went from the single static binary into these various components. So I mentioned sort of this container war era of different opinions, different ideas. Some people wanting Docker to move in different directions or to have different concepts about how some of these things are assembled. A lot of the major vendors who were also very active in the open source project. So, you know, we had people from Google involved in the Docker open source project. Microsoft was there, IBM, Red Hat, and many others. As people met to discuss sort of these differing opinions, the solution that everyone agreed to was to create this body called the Open Container Initiative and basically specify what we all could agree on would be what is a runtime of a container? What are those properties of how do I run a container? What's the command to run? Which namespaces to use? Which files to allow, you know, device files to allow the container to have access to? And so that body was formed in the summer of 2016. And out of that came not just a specification, but the actual code for run C. That was the lib container part of Docker, brought out and put into a separate binary. So again, a lot of I won't belabor reading this whole slide. Actually, I said 2016, it was summer 2015. And then over the next few years, many different companies worked together to reach the 1.0 specification, which seems like it wasn't that long ago, but now it's going to be 2 years this summer since the 1.0 version of the spec was reached. And there's two specs. So I mentioned the runtime, but also the image specification. So can we all agree on what a container image is? Maybe we have different implementations, but if we can all say what an OCI image is, then Docker can have their own tooling and others can develop their own tools as well. And so really thinking about it in the terms of like a Docker run command, OCI specified a JSON configuration that would match the kinds of things you might think would be in a Docker run command, like which volumes am I going to mount, which container base layer am I going to use, what command will I run, and all that gets encoded in this OCI configuration. Run C, again, is the implementation that actually knows how to read that spec and to look at a file system and to start your container for you. So you can almost think of today's Docker doesn't have the code that actually talks to Linux and sets up your container and starts that process. That's all in Run C today. And so Docker, again, is a higher layer above that. Again, there's a lot of words here, but effectively, Run C is that lowest layer that's actually talking to the operating system and the OS kernel to handle all the things about what we actually call a Linux container, why we even call it a container, all these isolation features. And so again, Run C has had a ton of releases. It has over 200 contributors. It's managed by this Open Container Initiative body that sits underneath the Linux Foundation. And it's used by more than just Docker, and we'll look at some of the other uses of it as well. But not to get lost in too many details, let's step up one level and talk a little bit about Containerd. Again, the idea here was that as Kubernetes came on the scene, you just heard in the last talk, you know, Docker had Swarm. All of a sudden, Kubernetes is gaining in popularity. And Kubernetes was using Docker as its runtime, but even the Kubernetes community said, you know, Docker's moving so fast, they're adding all these Swarm features. We just want a boring container runtime that Kubernetes can use to execute containers. We don't need the rest of the Docker suite of capabilities. And so that's really the source of the discussions that led to the Containerd project. Again, it was really a continuation of the idea that Run C was spun out from the Docker code base. Now you had a very simple binary that could execute containers. Containerd could sit on top of that and really do the management of Run C processes, so more of the daemon concept that Kubernetes could now talk to the Containerd daemon and ask it to start and stop containers that would make up your pods. And then Docker would donate this to a foundation, which again was the CNCF, the Cloud Native Computing Foundation. So there could, all kinds of groups, not just Docker, but others could collaborate around Containerd as this nice sort of common, boring, in a sense, container runtime that anyone could use to build higher layer tools. So again, Containerd has been around for a good while now. It was initially within Docker and then contributed out. So the 1.0 branch is we made the December 2016 announcement to contribute this code to the CNCF. That's when the 1.0 branch was created. And it became more than the initial branch, was really just managing run C, but the 1.0 version knew how to talk to registries, so you could push and pull images and more of the metadata and snapshot drivers like in Docker talking to the actual overlay file system. Those features were added Containerd. And then more recently, Windows support was added. Again, Microsoft is part of the Containerd community as well. I think in the interest of time, I won't spend a lot of time on the architecture of Containerd. Myself and others on the Containerd maintainer community have given lots of talks at KubeCon and other places. In fact, if you look at the deep dive from KubeCon Seattle, we've had someone with better drawing skills actually make a much nicer diagram of the architecture. So that's a great talk to watch on YouTube if you want to understand. It's got a very simple model that, again, really just sets up the basic needs for both Kubernetes to use Containerd as well as the Docker ecosystem to use Containerd. And again, all that sits on top of an OCI runtime such as Run C. So what does Docker today look like when we say, hey, I've got Docker 18.09? What does that look like? It's actually a collection of quite a few open source projects today. So the actual Docker client has moved out into its own project, so Docker CLI on GitHub. The Moby project, which is the original Docker engine, continues to be developed in that project. I just mentioned Containerd, which is a CNCF project in its own GitHub repo. Run C is under the Open Containers organization. All these get combined. You can actually go look at the Docker/Docker-CE repository. When Docker decides to make a Docker release, Docker engine release, they obviously will collect up all their dependencies, select versions that Docker release is going to be based on, and so you end up with a combination of various releases. Currently, I think 18.09 is using the very latest Containerd release. And again, so you can actually see that if anyone uses Docker for Mac and you look at the settings page, it'll tell you here's all the components that we use to create this release. And so you can think of, I think I actually put it here, Docker today is an open source based product. It's not just an open source project. Docker, the company, is putting together a product made up of quite a few open source projects, which both include free community products like Docker Desktop. And that's now, for those that heard the news from DockerCon, just as Dom said, 6 weeks ago. Seems like forever ago, but I think it was just December last year. They now have a desktop enterprise. There's the Docker Enterprise product. There's the Community Edition engine. There's Docker for Mac, Docker for Windows. All these are built out of many, many different open source projects. Some I didn't even talk about, such as all these kits, HyperKit, VPN Kit, Linux Kit. All these are developed in the open, but yet are used to build what you would call or know of as Docker on your desktop or Docker on your Linux server today. And obviously Docker, as a company, hopes to make money off that and obviously sell enterprise products based on these projects today. So really, as you can see, Docker has grown from sort of this single open source project into a huge variance of projects, some managed by Docker and some managed by foundations. But what that's allowing is really other projects, other products to use these layers not just to build Docker, but to build other things. And so if you look at runc, Red Hat has taken that and built an alternative runtime for Kubernetes called Creo. Some of you may have heard of that. They have OpenShift, Red Hat's OpenShift Kubernetes service is moving to Creo as its runtime. There is a sort of cloud-based containers as a service project called Cycle.io. The founders of that startup actually use runc directly, so they don't use the Docker engine, they don't use containerd. They've built their entire containers as a service offering out of runc, and there's a bunch of other OCI spec implementations such as lightweight virtualization, so Kata containers. If you've maybe heard of Intel Clear Containers or Hyper.sh, those projects have merged into a single project called Kata Containers. The high-performance computing community, there's now a startup that's creating something called Singularity that implements the OCI. There's other, Google has gvisor, IBM Research has Nabla. Basically, by creating a spec, you can see now there's potentially many variants of types of runtimes that are maybe more focused on a certain use case. But because of the layering now, this makes it very easy to have alternative implementations of how a container runs, but still use the higher layer ecosystem, whether that's Kubernetes, Docker, Docker Swarm, etc. Containerd, we're currently on a path to graduate in the CNCF out of the current stage that we're in within the Cloud Native Computing Foundation. And so we have a proposal PR that lists all these projects that are using Containerd today. Again, Docker is still maybe the largest user of Containerd, but Rancher is using it in a project. Google's managed Kubernetes service is switching from Docker to Containerd. Our IBM Cloud managed Kubernetes just switched from Docker to Containerd. Alibaba Cloud in China has built a huge number of projects around Containerd. Again, they potentially could be one of our largest users, again, given the size and breadth of the cloud ecosystem in China. So again, the point here being the layering of splitting out these pieces has allowed people to innovate in other ways, not just to be used by Docker, but to be used by other projects as well. I just mentioned Kubernetes has been using Docker as the runtime underneath so when you run Kubernetes, there's the node daemon kubelet that needs to actually talk to a container runtime to execute the containers. For a long time, that was simply using this Docker shim to talk to the Docker engine, which again drove Containerd, which drove runc. And so part of the Containerd project has been to offer the same capabilities by talking directly to Containerd. And so when I just mentioned that Google Cloud and IBM Cloud are in the process of making this switch, that's just an operational efficiency. It doesn't mean Docker can't continue to be used in that model, but for an operator, it may make sense to have a simpler stack on the server side of that managed offering. So again, there's a lot more background. There's some talks all about this, but I just wanted to show that as an example. I think we're over time. I mean, what I normally show from a command line is simply I can start a container from Docker, and then in Containerd's client, I can see that container, and I can even use runc to see that process running on the system under runc, just showing that layered approach. If someone wants to see that, I'd be happy to show that at the end. Okay. And so again, I think the summary here is that given the ecosystem is now agreed, okay, yes, we can all speak OCI. We can talk about OCI runtimes and OCI images, and now the actual Docker distribution API. So when you talk to a registry, the push and pull operations, that also is coming into the OCI this year. And so once we all agree that these OCI protocols and specs are how we talk, then everyone can play and interoperate in that world. And so, all the registries from the clouds, the private registries like Docker Trusted Registry and their enterprise product, Docker Hub, the open source project. All these speak Docker image format today, and the OCI image format is based on the Docker image format. But slowly, these projects are switching to speak natively the OCI image format. Again, with build tools now knowing how to speak in sort of pure OCI images. So whether you use Google Container Builders or Builda from Red Hat or Conoco or the BuildKit open source project from Docker, all these tools are going to be interoperable because they're all speaking the OCI image format, which means, again, all the runtimes, whether we're talking about enterprise products or the desktop products or the lightweight virtualizers like AWS Firecracker or Creo, again, all these products and projects will be speaking in OCI. And so that means I can build a container and I can run it in Docker on my laptop. I can run it in Docker Swarm. I can run it in Kubernetes. Cloud Foundry has adopted OCI. Some serverless projects, OpenFAS, OpenWhisk, Knative, are all based around container images. And so, not to say there haven't been bumps along the way, but I think we're in a really good place with the fact that, it would be a really sad place to be here 5 years into the container craze and say, oh man, this container image only runs on Kubernetes. If you want it on Swarm, you have to use this other tool. And so, really, I think the OCI and a lot of the standardization has led to a good place that I think we have a lot of interoperability and hopefully a lot of room for innovation for different projects to be able to continue down this path. So that's all I have. I think we're a little bit over time. I'm happy to take questions, or if people are ready to scoot out, I can just stick around. But
it kind of depends on how do we have to leave like straight at 9 or? I'm gonna, like, sometimes I've been in interviews where they're like, if you don't leave at 9, then the alarm will go off. So I'm not quite sure if that's the case here, or if we can.
Yeah, it's.
Are you coming to the pub?
Sure.
Is everybody else coming to the pub? I'm looking at the team on the right. Where are we going? Probably where, I don't know. Does any name a pub that's the best with the most space? Anyone? You work around the corner. Where are we going? Fine. Okay, so we are going to the pub. Just follow me somewhere, and then we'll. I stand out in the crowd, so that's probably fine. Well, give a great round of applause to Phil. And I want to thank all of you for coming and bearing with us with the with the flowing timeline and the pizza and stuff like that. So yeah, thanks Rightmove for being awesome.